Good morning, Honorable. Today we are going to discuss how BCD numbers are added and after adding that, how that can be converted to a valid BCD number. So, valid BCD number means this binary coded decimal. That means the numbers are from 0 to 9. And suppose that you have, suppose that this is a BCD adder. This is a BCD adder. Now we are going to give this is A, and these are two 4-bit binary numbers. These are two binary numbers, 4-bit binary numbers. That means in binary coded decimal, you have two numbers, and this is the output. And suppose that this is C, and this will, for example, this A can be from 0 to 9 and B is also from 0 to 9. That means you have two binary coded decimal numbers and you are going to provide this as input to a BCD adder. This is BCD adder, and after doing the summing operation or after adding, the result will be from 0 to 18. Practically 0 to 18 and theoretically it is from 0 to 19. That means maximum number here can be 9 and maximum number here also is 9. And 9 plus 9 only 18, and the minimum numbers are 0 to 0 and 0, then the result will be 0. And just like our adder, that means you have a 4-bit adder. When you are adding two numbers, then definitely you get the sum. And once you have this sum, for example, if you have a binary adder, that means you have two 4-bit numbers, and when these two 4-bit numbers are added, the binary sum can be, that means this is the carry generated. That means this is the binary coded decimal portion. Binary coded decimal, or this is the binary portion, and this is the carry generated. This is the carry generated. K is the carry generated, and Z3, Z2, Z1, Z0. That is the sum portion. Sum, and this is the carry generated. And when you have two binary numbers which are in BCD, that means the result can be, or the inputs are from 0 to 9 here and 0 to 9, and after adding this, the binary sum can be in one of this. That means we have to exclude this. That means 19 will not come, 19 won't come, and this is from 0 to 18, 0 to 18, and say this is the 4-bit portion and this is the carry portion. That means these two collectively forms the number, and as you know, this is 0, 0, 0, 0, and the equivalent is 0. Here also, when you are taking the BCD, if you are converting, that means if the sum generated is 1, 0, 0, 1, that means up to 9. If you have two numbers A and B, and the sum generated is from 0 to 9, you have to exclude the binary to BCD conversion. That means this is a valid BCD number from 0 to 9. But if the result generated is 10, what will happen? That means if binary sum is less than or equal to 9, that means up to 0, 1, 0, 0, 1. What is this? 0, the carry generated, and 1, 0, 0, 1 is 9. Then you have to bypass that. Then there is no need for any adjustment there. That means here you can bypass the result to the BCD. That means this is binary and BCD are same up to this point. Binary number and BCD number are same. That means you have two numbers which are in binary coded decimal. If it is a BCD number, that number is from 0 to 9, and once you have two numbers which are from 0 to 9 or BCD, and you are providing or you are giving those as input to a BCD adder, what will happen? The result can be 0 to 18. And after the summing operation, you have to have some arrangements. That means if the result is up to 9 or 0 1 0 0 1, that means the carry general is also 0. That means this is 9, and up to 9 there is no need to have any adjustment, simply bypass that result to the output. But if it is 0 1 0 1 0, that means this is 10. This is actually 10 in binary. This is 10 in binary. That has to be converted to 1 0. That means this is actually binary number. When two BCD numbers are added, the result can be this one. Result can be this. But this is not a valid BCD number. Why? This is only a binary number and its value is 1 0, but its representation is binary, and you have to convert this to 10. In 10 you have two digits, binary, two decimal digits, 1 and 0. That means this is the 1 and this one represents the 0. So for converting a binary number to its equivalent BCD number, what you have to do is here add 6. That means here 1 0 1 0 1 0 1 0, and you have to add 6 to that. That means if the binary number after addition, if it is greater than 9, what you have to do is you have to add 6. That means 0 plus 0 0, 1 plus 0 0, and the carry is 1. 1 plus 1 0, the carry is 1. 1 plus 1 0, again the carry is 1. That means when you are adding 6 to this, you get this. That means here you get this is 1 and this is 0. Okay. And if the sum is 11, what will happen? If the sum is 11, what will happen? In that case also we have to add 6. That means 1 0 1 1. If you are adding 6 to this, what will happen? 1 plus 0 1, 1 plus 1 0, carry is 1, 1 plus 1 0, carry is 1 0 1. That means this is 1 and this is 1. That means 11. That is 11. That means that process is repeated. That process you have to repeat. That process you have to repeat means here for all these cases you have to repeat the process. That means up to this is 15. In the case of 15, what will happen? We have to see. If it is 0, no, 15, 1 1 1 1, and if you are adding 1 1 0, what will happen? 1 1 plus 1 0, carry 1, 1 plus 1 0 plus 1 1, carry 1, 1 plus 1 0, and the carry is 1. Then this is 1, and what is this? 5. That means 15. 15, get 15. That means when you have converted 1 0 1 0 1 means this is 15. And if you are adding here, this is 18. 18 in binary, and when you are converting this again, 18 is this is 0 0 1 0. This is 18. That means this is 16 plus 2, that is 18. When you are adding 0 1 1 0, what will happen? 0 1 plus 1 0, carry 1, 1 plus 1 0, carry 1 1, and here 1. That means this is the BCD, which is 8, and this is 1. That means 1 8. That means this is the way we are converting a binary number into its equivalent BCD number. Binary number to its equivalent BCD number. Say when you are doing this operation, when you are doing this operation, here simply this is a circuit and here you have two inputs. This is A and this is B. A3, A2, A1, A0, B3, B1, B2, B1, B0. When these two are added, the sum is say S3, S2, S1, S0. This is 4-bit binary adder, and this is the carry generated. That means carry out. This is the carry out, or simply you are going to write CO. This is the carry output, and these are the sums S3, S2, S1, S0. And what I am going to do is, if where do we do these operations? See, up to if the carry, that means if the result is less than or equal to 9, there is no need to do any adjustments or any addition or something like that. Simply bypass this result. That means if the carry is 0, if the carry is 0 and this S3 is to S1 S1 is less than or equal to 9, simply bypass this to the output. Okay, simply bypass this to output. But if it is more than 9 and if the carry, see, if the carry out, see, here up to this point, here up to this point, there is no carry. And see, listen here, wherever there are carries equal to 1, that means when we have added two binary numbers, if there is a carry generated, then definitely you have to make that arrangement. That means add 0, 1, 1, 0. If you have a carry, if you have a carry for the binary sum, definitely you have to make the adjustment. That means if there is a carry, you have to do the arrangement. That means wherever there are carry, if carry in the binary sum, if there is a carry, if there is a carry, if there is carry in the binary sum, if there is a carry in the binary sum, add 0, 1, 1, 0 to output. That means, see, this is the binary sum, and here up to this point there is no carry, and here there are carries. That means here now we have taken these 4, and for all these 4 there are carries. So wherever there are carries, that is the first thing you should remember. Wherever there are carries in the output, then you have to add 0, 1, 1, 0 to the output. That means these 4 cases you have taken. These 4 cases. Now you have to take these 1, 2, 3, 4, 5, 6. See, using Karnaugh map we can do this, but here using Karnaugh map is difficult because here there are 5 variables in the Karnaugh map. So you have to see, or when you are there is a pattern in this and you have to find out the pattern, and I will tell you how we are doing that. That means here for all these cases, here this portion, that means Z3 is 1. That means here we have taken these 4 and in all those cases the carry is 1. Carry is 1. And if there is a carry in the binary sum, add 0, 1, 1, 0 to the output. Okay. Now, see these 6 partial sums or 6 binary sums. In all those cases, you have 1 here. But if you are adding 0, 1, 1, 0 to the result, wherever there are Z3 is equal to 1, then here also that is added. Here also that 0, 1, 1, 0 will be added here also. Okay. So you have to exclude these two cases. You have to exclude these two cases. That means wherever there are ones in Z3, you have to make the addition, but you have to exclude these two. So see the difference between these two and these. Here 1 0 0 and 1 0 0. Here for these two, here there is 1, here there is 0 and here there is 0. But unlike that, here 1 0 1 1 0 1 1 1 1 1 1 1 1 1. That means here this is 1, and apart from that either this or this is 1. Okay, that means here in this case, these two cases, this is 1, but these two are zeros. But unlike that, here these are ones. Apart from that, this is 1, these two are ones, and these two are ones. That means either this portion, either Z1 or Z2 is 1 for all these cases. Okay, then I am going to give you, that means where we have to add 0, 1, 1, 0. First case is if there is a carry in the binary sum, add 0, 1, 1, 0 to the output. Number 2, if Z3 is equal to 1, that means if Z3 is equal to 1 and Z1 is equal to 1 and 0, 1, 1, 0 to the, see here Z3 is equal to 1 and Z1 is equal to 1, Z3 is equal to 1 and Z1 is equal to 1, and here also Z3 is equal to 1, Z1 is equal to 1, here also Z3 is equal to 1, Z1 is equal to 1. That means here I have considered the cases of this, and this. That means here for all these 4, this and these are ones. Now we have to consider these two cases, and in those two cases Z2 is equal to 1 and Z3 is equal to 1. That means case number 3, if Z3 is equal to 1 and Z2 is equal to 1, and 0, 1, 1, 0 to the result. If Z3 is equal to 1 and Z1 is equal to 1, add 0, 1, 1, 0 to the result. If Z3 is equal to 1 and Z2 is equal to 1, Z3 is equal to 1 and Z2 is equal to 1 means this is considered again for these two also same. That means now this is the problem is solved. That means here you have to make the arrangement, or you have to add 0, 1, 1, 0 to the result, in for these three conditions. So see, that means we are going to have an AND circuit. We are going to have an AND circuit, and simply you are giving this to another 4-bit binary adder. Here we are giving this result to a 4-bit binary adder. Again, we are going to give, and that binary adder is adding this, and that means S3, S2, S1, S0. And if these three conditions, if any one of the three conditions are satisfied, then add 0, 1, 1, 0 to this. That means this has to be fed to another BCD, another binary adder, 4-bit binary adder, and if any one of these three conditions are satisfied, then we are adding 0, 1, 1, 0, and if these conditions are not satisfied, we are simply adding 0, 0, 0, 0. That means simply bypassing the result. Okay. See, now I am going to have these three conditions. I am going to have an expression that means say C star is equal to, that means if this K is 1, definitely you have to add, that means this is K. Or next is, if Z3 and Z1 are same, Z3 and Z1 are ones, that means K plus Z3 Z1 plus, if Z3 and Z2 are ones, again we have to add 0, 1, 1, 0, that means Z3 Z2. That means this is the expression for, that means by looking at this, you can take a decision upon whether to add 0 or 0, 1, 1, 0 or not. That means if K is 1, definitely you have to add 0, 1, 1, 0. If Z3 and Z1 are ones, you have to add 0, 1, 1, 0 to the result. And if Z3 and Z2 are same ones, then there again we have to add 0, 1, 1, 0. That means by looking that means you have to generate a combination circuit for this, and once this is available, then you can easily decide upon whether you have to add 0, 1, 1, 0 to the result. So for that, what you are going to do is, here this is S3, S2, S1, S0, and again you are having an adder here. This is again a 4-bit binary adder, and here you are giving this. Okay, and here now you are going to have another input which is 0. First and last bits are 0. Now here we are going to have an expression, that means here you are going, that means this is the carry output, and carry output is equal to, that means you are going to find out this C star. That means that is actually, this is not S3, S2, S1, S0, this is Z3, Z3, Z2, Z1, Z0. Okay. Now you have to find out Z3, Z1. Z3, Z1 is Z3 into Z1. That means here you have to take this, and from here, that means you are multiplying that 2, and this is Z3, Z1. And what is Z3, Z2? That means again you are going to take, and this is also you are going to take, and this is Z3, this is Z3 Z2, Z3 Z2, and this is Z3 Z1, and this is the carry. Okay. Now we are going to have an adder circuit. That means you have found out this is actually in our discussion. This is not CO. This is K. Okay. That means here see now you are going to add these three using an OR gate. We are going to add these three. That means this is the OR gate, and we are simply providing these three are the inputs, and here we are going to provide these two. Okay, that means see here this is the carry generated, and if the carry generated is equal to 1, then definitely this will be equal to 1, and this will become 0 1 1 0. If Z3 Z1 is equal to 1, again this is an OR gate, and using this OR gate here it is 1, that means this is 0 1 1 0, and Z3 Z2 is equal to 1. Z3 Z2 is equal to 1 means again this will be 1, and for all these three cases it will generate 0 1 1 0. The output of this will be 1, and the input given to this 4-bit binary adder will be 0 1 1 0. For all other cases, the input to this will be 0 0 0 0. That means this is just bypassed. That means here this is the result: S3, S2, S1, S0, and this is the carry, and this is the right BCD, and this is the that means right BCD and left BCD means if you have converted this to this, then this will be 1 and this is 0. With this, this is the end of the session on BCD Adder. Thank you.